IITJEE.
Hi, Barry Science Lab!
Alright folks, today we're going to be talking about distance-velocity relationship. Let's read the problem. Two cars with initial speeds of 2v and v lock their brakes and skid to a stop. Assume that the deceleration while skidding is independent of the speed. The ratio of the distances traveled is. So here's the situation. We've got two cars. One of them has an initial velocity of 2v. The other one has an initial velocity of just v. So we can draw that one as such, v. Now here's the thing. They lock their brakes and skid to a stop. So should we worry about the acceleration? Well, the problem tells us not to. Deceleration is independent of the speed. So the question is, what's the ratio of the distances traveled between this guy and this guy? So how do we do this? Well, we know at least something. We know that at the end, their velocity is 0 for both of them. The only question is, how much distance did this one travel versus this one? And of course, we got to find the ratio of those distances. So here's what I'm thinking. The first one, as we can draw with a VT graph, the first one starts with some velocity 2v. Second one starts with a velocity v. So here's 2v, here's v. And they both end up with 0 velocity at the end. So here's how I'm going to depict that. 0 velocity, they both end up on the x-axis by the end of their journey. Now, before I even get into anything, you can see quite clearly that the distance traveled by the guy who started with a velocity v is exactly 1/4 of the distance traveled by the guy who started with a velocity of 2v. And so we can already begin conjecturing that our answer should be 4. But let's try to do a more mathematical reasoning of this. How do we do that? Well, let me show you. We can use the distance formula. We're told that distance is equal to VIT plus half AT squared. VIT plus half AT squared. Now, assuming that acceleration has no voice in this story, we can say that the first one starts with a velocity v. So we have VT plus half AT squared. But remember, distance is equal to velocity times time, right? So distance over velocity is equal to time. So velocity and time have a linear relationship. That means the guy who started at v ended at a time t. The guy who started at 2v ended at a time 2t, twice the time. And so what does that mean for us? Well, let's check it out. Let's find the area of these guys so we can find out their distance. The area of the first one is 1/2 vt. Area of the second triangle is 1/2 base times height. And so what does that give us? That gives us 2vt. And so 2vt is quite clearly 4 times half vt. And so once again, we end up with the same conclusion. The guy who started with a higher initial velocity, double the initial velocity means double the distance traveled. Thanks for watching this episode of Physics. We'll check you out next time.
Embedded plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.